Okay. All right. Say hi to Kate. I don't think she heard that. Okay. Let's cycle through the different values of tangent. What's the tangent of the angle right, which is the tangent of 0? That may distract you, and I'm sorry. It's not doing that on mine. Yeah, that's 0. What's the tangent of this angle right here? Tangent of the angle up? Undefined. I'm going to cheat. I'm not going to put undefined down. I'm going to put that. You know, that thing that I told you don't ever put, but you can, but please don't, but do. I know. I get it. Kate can't see this, but the little recording marker on the corner is blinking for everyone. I'll research how to get rid of that later. Then we go to -1, because one of the values is negative, one's positive, but they have the same ratio. Then we go to -0, or just 0. Cycling back down into quadrant 3, we get 1. X and Y are both negative. Then we get, yeah, we're just going to call it infinity, but you can. Then we're going to go to -1 and right back to 0. So given this, and you know, I didn't really even think about that. I am going to put negative infinity in a way, but we're going to put undefined because whoever said negative infinity is actually very correct when we get to one-sided limits. That's extremely, extremely important. We're going to put undefined. Freddie, was that you? What? Who said negative infinity? I want to give credit. Give credits to you. That was you, Park. Impressive. When we get back down to this, I really do want you thinking, though, that, guys, we start at 0, and we move through a cycle of 0, 1, undefined, -1, 0. And we achieve getting right back to 0 in half the time it took us to do it with sine and cosine, which means that the period is half that of sine and cosine, which means the period, the default period is not 2 pi, the default period is pi. And that means the period will be pi divided by b, because when you divide by b, that's the shifting that happens, or I should say the stretching that happens. So tangent duplicates 2 cycles within a 0 to 2 pi. It goes 0 to 0 that way, and then you go 0 to 0 down again. And the graph is going to look the same for the 2 of those. You cycle through all the tangent values because all the tangent values in quadrant 1 are the same as they are in quadrant 3. All the tangent values in quadrant 2 are the same as they are in quadrant 4. It's the same cycle. So tangents, first thing to know, the very first thing to know, and I'm going to rewrite it under here, is that tangent has a period of pi over b. And we're going to summarize that with all of them, because if tangent has a period of pi over b, so does cotangent. Which means that secant and cosecant will follow what sine and cosine are doing. Okay, that's the first thing to know about tangent. We're actually going to now graph the function y equals tangent x on the axis like we would with all of them. And we're only going to use those values that we did, and I'm going to t-chart them here on the right side for just good measure. Theta, well, I should probably just do x and tangent x to keep it in xy form. 0, 0, pi over 4, 1, then pi over 2, what? Yeah, infinity or undefined. Either way, you're going to put the same vertical asymptote that you would. Then 3 pi over 4, -1, pi, 0. Those will be our basic points for one complete cycle of tangent. Within graphing y equals tangent x, we know that our a value is going to be 1. Our b value is also 1, which means the period is pi over 1, or pi, and hk will be 0, 0. That doesn't change. So I'll put a grid down, and we're going to graph these points. Since I'm going from 0 to pi and I'm doing it in fourths, I'm again going to use fourths to do this. Starting at 0, 0, shifting or moving 4 units to the right will make this be pi. I'm also only going up 1 and down 1, and I'm just for this graph going to keep that scale where it would be normally, 1 and -1. And I'm also going to draw a single frame box. The frame box is a guide so that I know where you are. I know what you're doing. I basically means I know what your shiftings were by just looking at it. But your graph will not be contained to the frame box. You'll see what I mean here in a minute. We start at 0, 0. That's a point we just graphed. Then we go to pi over 4, 1, which is going to go like this. Then we go to pi over 2, infinity. Draw your vertical asymptote. 3 pi over 4, -1, and then right back to 0. In every single one of these periodic functions, you start and end at the same y value. So how do you draw this? Oh, all three. Izzy?
Well, you connect the first two and then you approach the asymptote.
We're going to go like this, and then like this. Now, to really see tangent, you should probably draw a cycle on the left and a cycle on the right. So we're going to do that and draw a couple more. You shouldn't have to do another frame box to do that, but do put down the asymptotes. Additionally, because tangent is contained in half the cycle of sine and cosine, I will still say draw each eta, but each eta, there are only 2 etas in a tangent cycle. An eta is what you get when you go from the start up to the asymptote. And I'll do a second cycle off to the left. And there's one, and there's one. Those are tangent lines. They continue infinitely far left and right. If I want to be clever and technological and say, let's circle this and graph it and hope that this recording doesn't stop. Math. Oh, graph in 2D, insert. There we go. There's tangent at its most basic. Couple of things I want to note about it. I'm going to ask that you still do a frame box for a single frame, because whereas you're breaking the frame box by drawing, it does tell me that you have an understanding of how the vertical stretch is going to work. Okay? The A value is going to be completely indicative of how far vertically that stretches. So very, very far stretched tangent lines are going to look like this. They're going to look very like that. Whereas ones with A values down are going to look more like sharp turns, and that's going to be a slight difference. They can also be stretched horizontally depending on how you scale it, but you just need to tell me what your scale is. We don't need to go much more crazy than that. Okay.
Wait, whenever we're drawing like trig function graphs, you always want us to draw a table?
I always want you to put a frame box and define your components. Your A, your period, your H and K. I don't need a table of values unless you really want one, but I don't. Let's do cotangent and see its distinction. Y equals the cotangent of theta. I'm going to put a grid down again, and we can do this in one of two ways. I can go through the whole circle and kind of, well, let's not do theta, let's do x. I can go through the circle and again do the same things, or we can be smarter about this. What's the relationship between tangent and cotangent? Reciprocal. So what started off as a point that was on the baseline, which is 0, turns into the reciprocal of 0. What's the reciprocal of 0? Undefined. And undefined presents on a graph as a vertical asymptote. And just to give you guys a little sense, I'm going to steal the same frame box from before. and still steal the same markings, because all we're doing is we're just going to take reciprocals of the points. The next point was the point 1. The y value was 1. What's the reciprocal of 1? 1. That point stays. The next point was an asymptote. What's the reciprocal of an asymptote? 0. That point goes back down to the axis. The next point was -1. What's the reciprocal of -1? So I'm hearing 1 or -1. Which is it? What's the reciprocal of -1? -1. -1 is its own reciprocal. The definition of reciprocal is the number that when you multiply it by, you get the number 1. So -1 is its own reciprocal. Don't confuse that with opposite reciprocal, which is what you get when you have perpendicular slopes. Okay. So the reciprocal of -1 is -1. And then finally we have the reciprocal of 0 again, which starts and ends with an asymptote. So cotangent is different from tangent only in the sense that you're starting and ending at your asymptote, whereas with tangent you start and end at the 0 points and you pass through. Well, you never pass through an asymptote. You'd be ending the world if you did that. But same shape. Just put your pencil in the middle. Draw each eta separately. So I'm going to go up towards the left to do one and down to the right to do the other. And then because I want to, I'm going to repeat the shape a few more times, left and right. So tangent graphs are kind of boring. It's just 3 dots in sequence, rising or falling. And I totally didn't write that one right, so back up, get that down. Let's shift left, there we go. Dot, dot, dot. And then up, and then down, and then up, and then down. Yes, Izzy?
So would the opposite, or the negative of this just be flipped, kind of?
Oh, so close. The negative would be flipped. And then can you flip it to make it look like a tangent, but what else would you have to do? You flip it so it has the same shape. What else do you do to make it be tangent?
Oh no, I was saying like the cotangent, if you add like a negative.
If you add a negative, where?
Like would it be just a reflection of the...
It is, but so like if I put a negative in front of cotangent, you mean? Yeah. If I put a negative in front of cotangent, this is going to flip and go the other way. Now I'm asking you an additional question about what else would you have to do to make it slide and perfectly lay right on top of the tangent graph?
Shift right 2,
yeah.
So x minus 2.
Shift right 2, so x minus. So if I make it negative cotangent of x minus how far to the right? What's 2 boxes in this? Pi over 2. That the negative cotangent of x minus pi over 2 should actually be equal to the tangent of x. I'm going to argue you already know that. What? It is the cofunction identity combined with the even-odd identity. If I take this negative and put it back in, which I can do because cotangent is an odd function, I get the cotangent of negative x plus pi over 2, which is actually the same as the cotangent of pi over 2 minus x. And that is the cofunction identity between tangent and cotangent. So it was a combination of the cofunction identity along with the even-odd properties that let me say that these are the same. But you can tell that with the graphs. Okay, I'm going to give you a shifted one, and I want you to graph this. I'm going to go y equals -3 tangent of -1/4 x plus pi minus 1. Make sure that you pull your b value out like we've been doing. So -1/4 factored out looks like a minus 4 pi. Then I've got a negative 1/4. I don't like the negative 1/4. Even odd properties. Does it go away, or does it make the leading to negative 3 become positive? Yeah. Tangent's an odd function. Odd functions mean this negative swings out. 3 tangent of 1/4 x minus pi over 4 minus 1. This is now what you're going to be graphing. That's a better graphing form. And your first steps really are about converting your not so good graphing form into good graphing forms. Your leading coefficient, your a value. B is 1/4, so period is not 2 pi divided by 1/4. This is tangent. Pi divided by 1/4. You can put 4 pi. And the shifted HK is a right shift of 4 pi and a downshift of 1. All of those pieces still reflect where your frame box is. If you keep it all about shifting frame boxes, then it just becomes about drawing things correctly. Yes, Simba?
For the final tangent function, should it be an x plus 4 pi if you took the negative out?
It was a plus originally.
Yeah, so if you multiply it.
Oh, it's not, because it's just one of the negatives I'm factoring out. I've already factored this as a factor. It's already a multiplier. So I'm pulling the negative out of the single multiplier. Okay. Let's go. This is a right shift of 4 pi, and my period is 4 pi. It's always nice when that matches up, because now I can just shift right 4 units and call each block a pi. Remember, you can set your scale really to whatever you want. So this is going to be 4 pi and negative 1. Let's make my vertical scale be exactly just box by box. So that's my new shifted left center frame box. From that point, it's an amplitude of 3. I'm going to go up 3 and down 3. And the period is also 4 pi. And since I'm setting each horizontal box to be pi, I'm just going to go over in fourths. There's a frame box. It's good form if you have a frame box that's shifted right away from the axis to just put another cycle on the left or another 2 cycles on the left. We're going to do that because tangent really looks terrible unless you draw a few of them. But tangent's the one that starts at the baseline, and I'm going to draw the baseline. You can do this. You don't have to, but sometimes I put the baseline as a dot so you can kind of see where that shifted axis is. Starts at the baseline, ends at the baseline. Halfway in between the 2 baseline points is a vertical asymptote. Halfway in between the vertical asymptote and the first point is an up point. That reaches the top of your frame box. That's why you have a frame box there. That point should match, as well as the down point here. And then you just sketch up, sketch down, and then perhaps draw just a few more of these. So another asymptote with another down point and another up point and another baseline point. Then another down point, another asymptote, and another up point. That should be 2 more cycles. Draw one down, up, down, and this one kind of came here. There. That's 2 more cycles to the left. Yes, Aiden? If it's a negative tangent, then your up points become down points, your down points become up points. It looks like cotangent. What? This is a tangent. This is not a cotangent. So look back at your tangent graph. That one started. Better question is this one right here. This is what makes it tangent. Look at your single cycle. It starts by going up, and then it goes down. So that you kind of have to keep your frame box straight to see what's happening. Okay. To review. for tangent and cotangent, period equals pi over b. All else, period equals 2 pi over b. Capiche? Also review. Tangent's frame box, which we're going to sketch a little box here, starts at the baseline, moves up, then moves really far up to an asymptote, then comes in from the other end and comes right back. It looks like this. That's one of tangent's repeated units. Cotangent, its frame box is a little different. It starts at the asymptote, it ends at the asymptote. Halfway in between the two asymptotes, it crosses the baseline. But its points are the same as where tangents were. It's maximums and minimums. It starts up and it goes down. So it goes in the other direction. That's one of the repeated units of cotangent. Yeah?
You know how you want us to draw like multiple periods for tangent?
Just 2 at the minimum. Maybe more.
1 for cotangent since
Still did 2. I want you to get that sense that it's compressed. Your own, like, to get through a full cycle of cotangent actually truly means you're drawing 2 of them, because that's 0 to 2 pi. Okay, we're ending with the easiest graphs of them all, the cosecant and the secant. So I'm going to start complicated, because why not? I'm going to have you graph y equals -3 times the secant of -1/2 x plus pi over 2 minus 1. That's a lot of shiftings for a graph that you have no idea how to graph right now. Or do you? We've hinted at a little bit of things that you've done. We've hinted at the relationship between tangent and cotangent, understanding how the reciprocals work. So the first thing to know about graphing this, other than the fact that let's transform it into a better form, which means it's secant, even or odd? Even. Secant is even, which means that negative is going to get factored out and disappear into nothingness. But we still want to factor out a -1/2 x minus pi over 2, kidding, x minus 2 pi. Nope, x minus pi. That's better. Minus 1. And then that negative is just going to go away. So yes, I am rewriting the entire thing just to drop a negative, but these are notes, so that's why. And I'll slide this word even down a little bit to justify my moving from this step to this step. Secant follows cosine. And to graph secant, I'm actually going to write this down. To graph secant, first graph its reciprocal, aka cosine. To graph cosecant, first graph its reciprocal, sine. You're going to use the graph of cosine as a guide. Once you get the graph of the cosine down, graphing the secant's silly, and I'll show you that. So let's pull the properties down for y equals -3 cosine of 1/2 x minus pi minus 1, because that's really what we're going to be graphing. Properties, a value is 3, or you can put -3. Since the b value is 1/2, this means that the period is, we're back to 2 pi divided by 1/2, which we all know as 4 pi. And my hk is equal to pi -1. All that comes down to a graph that we will start graphing. hk, we're going to make, since my period is 4 pi, we're once again going to make every horizontal box just be a single pi. So this is 1 pi to the right and 1 down. A value is 3. I'm going to go up 3 and down 3. Right 4. I'm going to draw a frame box that's going to contain 1 cycle of cosine. I'm only going to put the points down. You don't have to draw the cosine graph, but we're going to start with where the points would be. Cosine is a graph that starts at its maximum. It ends at its maximum. Halfway between the two maximum points, it crosses the minimum point. Halfway between those 2 points, it crosses the baseline and crosses it again there. Okay? I am going to repeat these 5 points 2 more times to the left and 1 time to the right because I really want you to see this graph. So take a minute and do that. They form a nice little V. There's 2 times to the left, and here's 1 time to the right. You can, if you want to, draw the cosine graph. You don't have to. It may crowd it. It may not. I'm just going to put 1 cycle in. Because what we're really doing now is the game of reciprocals. Okay? Every time that this graph crossed its shifted baseline, this is its shifted baseline, by the way. This was the 0 points. This was the y-axis. Yes, Izzy? Was it negative? It was. Oh, good catch. Well, crap. No, we fix. No, I'm fixing. I don't have to erase any of my baseline points. I just have to erase my mins and maxes. It's okay. I wonder if Kate caught that. Well, that, strictly speaking, that hasn't happened yet. We're like looking into the future here.
We should make that.
No, because then she could come back and say, like, no, she would tell us. Okay. Down and up. Okay, that's better. And this graph looks like this. Okay. Every single time that this graph crossed it, the shifted baseline, what's the reciprocal of that represent? Or that was 0. Those were zeros. So what's the reciprocal of those points? Carly, did you say it? I heard it. Sorry. Asymptotes. Every single time that it crosses the shifted baseline, those are now vertical asymptotes. That's a lot of vertical lines to draw. I'll wait. And since it crosses the baseline a lot, you're going to draw a lot of vertical asymptotes. This is happening every single time that this graph crossed what would have been the x-axis. Because when it crosses the x-axis, that's a 0, and the reciprocal of 0 is undefined, even if it's shifted. Okay, so those are my asymptotes. Now we're going to do exactly the same thing we did with cotangent. Every time that the cosine graph reached its maximum, that was like it reaching 1. What's the reciprocal of 1? Itself. Every single other point on that graph it stays. The maximum stay, the reciprocal of 1 is 1. The minimum stay, the reciprocal of -1 is -1. I'm going to darken those points in with a purple pen because I can. We're going to keep those. You don't have to, but you can. Darken, 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 darken. So you keep the mins, you keep the maxes, and you make your zeros become asymptotes. And then all you do is put your pencil on each of those points and draw it out to the asymptote. Down, up. Think of it like a sine or cosine graph that is blown up. Instead of coming inwards, it has gone outwards. And it's really kind of fun to graph sine and cosine on the same graph and see the wave in between. That is a cosecant or a secant graph.
The red thing was all the way to next week. You just didn't know.
Yeah, the red thing would go all through. I just didn't draw it because you can't. And you can graph sine or cos. I'm not going to count off on a cosecant or a secant graph if you decide to draw the sine or cosine graph completely within it. This is what it would look like. But please know that the cosecant or the sine or cosine graph is not actually considered part of the secant graph. It's just more like a guideline. There's everything graphed in. Looks pretty. But You guys clear that your actual secant graph is just this and just that?
So should we be able to go straight to those blue?
You can. I mean, you don't. If you think about it, you don't actually have to connect these. You
Yeah.
should put these points down, so you're using this guide point, but you don't have to draw that at all. It's just there as a guide. Okay, I'm going to stop recording.